All right, picking up from the last video, this is part 2 of converging, diverging, as well as first and second differences. We just talked about how to find first and second differences. Let's go ahead and use that information to be able to build a new sequence and make sure we can create it. Now, what's nice is that I think we have 1, 2, 3, 4, 5, 6, 7. So we don't have to deal with much on the L1. We just need to add a 7 there. And then we're going to put in the values. We got 5, we got 14, we got 27, 44, 65, 90, and 119, 119. Now, I'm cheating a little bit. I should be doing this. To get from 5 to 14, you got 9. To get from 14 to 27, what is that? That's 13. Is that right? Yes. And then here, you're going to get, I believe that is, it looks like we're adding 4, so that was going to be 17. This is my guess is this is 21. My guess is this is 25. And this right here is 29. If we do our second difference, use a different color. Go from here to here, that's 4. Here to here, that's 4. Here to here, that's 4. Here to here, 4. And here to here, 4. So we can actually say, you know what? We're good to go. That is going to give us a quadratic. We go to put our data in like I did before. Go down to quadratic regression. Press enter. And yes, it actually works. So we have 2n squared plus 3n. So we would write a sub n equals 2n squared plus 3n. We don't have to put plus 0. We can leave it like that. All right. And that concludes our first and second differences of sequence. Now we're going to move into infinite sequences. So those are sequences that have that go on forever, and they have end behavior. Looking at these two different sets of graphs, we can see that on the left we have converge. Everybody say converge. Converge, good job. And then on the right we have diverge. So we have converge, which means you actually approach a value. Like you can see in these two pictures, it looks like these values are becoming, these different values are kind of zeroing in on one specific value as we go to infinity. And for diverge, it looks like these are approaching positive or negative infinity, and there's no real bringing it to a value for those. So we're going to take some sequences like we've talked about 2 days ago, and we are going to decide, well, does this converge or diverge? If it does converge, then what does it converge to? So the first thing we need to see is what is happening here. For number 1, well, actually, for this first one, I want you to pause the video, see if you can figure out what's happening. Give you 30 seconds. Ready, go. Okay, with the first one, hopefully you recognized it was arithmetic. Okay, and if we were, I can't remember what we're adding. What are we adding every time? Is it 3? I'm not sure. But you're adding the same value every time. And if that is the case, and we keep adding forever, we are never going to approach a single value. This is always diverge for an arithmetic sequence. Arithmetic sequences do not converge. All right, pause the video and check out this second one right here. All right, this problem, let's think about what's happening. Hopefully you said that this was geometric. And for this one, r is equal to -2. And as we see, we're going from 3 to -6 to 12 to -24, and boom, boom, boom. This actually models kind of like what we see here, except for it's going back and forth like that. And because it is going further and further away from one another, this also diverges. Okay. They're bouncing off further and further away. Let's see, for this next one, go ahead and pause your video and try this out. 14, 11, 8, 5, and 2. Aha, I tried to trick you. This is arithmetic just the other way. So if it's arithmetic, we already said that it does not converge, it diverges. But this one diverges and goes to negative infinity. So we would say diverge for this guy. All right, and the last one, pause the video, think about it, see if you can figure out what it does. For the very last one, you should have recognized that this is geometric as well. And it is going from 60 to 20 to 20 over 3 to 20 over 9. It looks like the R value is, we're multiplying by 1/3 every time. And if that's the case, and we a third and third and third and third forever, we're actually going to approach 0. So this converges to 0. If you can imagine, somebody said take a pizza and slice it into 1/3, then slice that into 1/3, and slice that into 1/3 forever, you will never, you could technically go on forever, but you're approaching 0 amount of pizza. Really small. All right, let's go ahead and talk about some cases where a sequence is listed as kind of like a function. So you can see these top three, this guy, this guy, this guy, they're written as functions. So we can plug in 1, plug in 2, plug in 3, and that's how we would create our sequence. For our purpose right now, we just want to know, does it converge or diverge? And so we can remember a little bit about the horizontal asymptote rules, which give us guidance on what happens to infinity. So for that rule, we're looking at what the degree is on top and on bottom. For this one, the first one, the degree is bigger on the top. So that, if you remember from horizontal asymptote rules, is that we are going to go towards infinity. And that means that this diverges. Okay. For the second one, the degree is 1 on top and 1 on bottom. Those are the same degrees. Therefore, this converges to, do you remember? Leading coefficient over leading coefficient. So 3 over 1. So that converges to 3. And the last one, the degree is bigger on the bottom. So that means that we need to remember if it's growing bigger on the bottom, then that approaches 0. So converges to 0. Hopefully you remember some of those things. If not, now's the chance to go back through and remember them. Well, let's look at the bottom left. It says 1 over 1, 1 over 2, 1 over 3, 1 over 4. The best thing to do for these types of questions is to write them in terms of n. So what is happening to the 1 or the 2 or the 3 or the 4 as I move in my sequence? And I can see for this one, I'm getting this, right? My first term is 1 over 1. So that's where the 1 goes. 1 over 2, 1 over 3, 1 over 4. Now what's the degree? The degree is bigger on the bottom. So this converges to 0. All right, now we got a little tricky one. I see it's similar in the bottom, but I'm going to have you pause the video and try to figure out what the general term is for this. Pause the video now. See if you can do it. Okay, so just like the last one, I know that n is the denominator because 1, 2, 3, 4. And I know the top is adding 1 the same way that the bottom is. It's just off by 1. So if I were to take n and add 1 to it, I would get my numerator, right? If I plugged in 1, I'd get 2 over 1. Plugged in 2, I'd get 3 over 2, 4 over 3, so on and so forth. So for that, we have a degree of 1 on top, a degree of 1 on bottom. Guess what that means? That means that we are approaching 1. Converging to 1.